Welcome to vectors. We're going to look at what they stand for and some operations with them. First, let's take the vector 4, 6. Notice the arrows. That denotes this as a vector, not as just a point. However, we still do graph it as if it were a point in order to find some information about the vector. So 4, 6 as a point would be here. And what we're now going to do is I'm going to do a line to it. From the origin. So from 0, 0, and I put an arrow going towards it. So then I would denote this as 4, 6 with the arrows, not the parentheses. What we're going to do is find two different things about this. Right? So this first is a vector. A vector is an array which has a direction and a distance. So we're going to find those two things. So first part of this, for part 1, is called this. Number 1, we're going to find the magnitude. The magnitude we can think of as distance. And we use the symbol double line, like absolute value lines, but doubled to mean the distance. And the way that we figure this is we do the absolute value of, that's the one it is sort of like the X and sort of like the Y. It's not really an X and Y. It does help us graph it that way, but it's not really it. Okay? And what we're doing is finding the distance from 0, 0 to, well, doing 4, 6 means from 0, 0 automatically, but I'll leave it that way because I want you to get in the habit of thinking of the arrows. So it's really going to be 0 minus 4 squared, sort of like x minus x. Okay, and this being the x1 because that's the x where it's 0. Plus 0 minus 6 squared, and this is like the y of 0 from the origin minus the first y, or the only y that we have. Okay, well, now let's actually start those calculations. That's negative 4 squared, square root of all this, plus negative 6 squared. And since negative 4 squared is 16, positive 16, and negative 6 squared is positive 36, we get a square root of 52 units, which is approximately equal to 7.3 units. And that would be our answer. Actually, both of them are acceptable as the answer. Okay, 5 square root of 52 and 7.3. So 7.3 is more practical in one sense, but 5 square root of 52 is exact. And that's the way to think of this. That this is the exact answer, and this is the approximate answer, and these are for the magnitude. Now, let's think about direction. So the second part of this is the direction for it. And for the direction, we start at the initial side and we go here. So for that, we probably need a protractor. In fact, almost certainly we do. If you get a protractor and you have the lines right, it's going to be pretty close to about 56 degrees here. But now, here's the thing to watch. out for is that there are two ways to have direction. A, the normal, simple 56 degrees coming from the initial side or from the 0, 0. From initial side of the graph. That's called the initial side. But B is what we call the ordinal direction. Left out an E there, so let's fix that. Now, you know that's north and that's south, and east is here and west is here. But in between here is northwest. In between here is northeast. This is southeast and this is southwest. We use these with a degree in between them. So for instance, we would do north and a degree in east, or north and a degree in west, or south and a degree amount west, south and a degree amount east. So we need to have some kind of number in here in between them for the actual degree. So for instance, in this one, here is north and here is east. But northeast is anywhere in this quadrant. What we want is the very specific amount of degree. But the difference for us is it's not 56. The north or the south always comes first. So we have to measure the angle coming from the north to the east. That is simply going to be 90 degrees minus the 56. I can put that up on top because so it's 90 minus the 56. Okay, which gives us a, what, 34? I believe it's a 34-degree angle. That's how we get 34 degrees in there. So coming down here, I know that I'm doing a north, and I'm doing 34 degrees, and I'm doing west. And we get that 34 from 90 minus the 56 degrees, which we got from using a protractor. Use a protractor. So these are the two things we have to do. We have to find the distance. We have to find the distance, which we call magnitude. And we have to find the direction, which we can do as the from the initial side or the ordinal direction. Let's look at another example where it's not the quadrant in the first quadrant. This one will have negatives. All right, so we don't have to graph it first. So I'll wait on that and I'll graph it in a moment, because the first thing that we need to do, and this will just do it one, is to find the magnitude. That's what the double square roots mean. Just looking at that, or not double square, to the double absolute value lines mean. You look at that, and that's like telling you, find the magnitude, okay? So if we're going to find the magnitude, we're going to do this, and we're going to do 1x minus the other x. But that's going to be x0 minus the x of this one squared, plus a y minus a y, and it's the original y minus the y that's in. It's here, because this is the x and the y. They're not really x and y on x for graphing purposes, but still. So the magnitude is 0 minus -5 squared plus 0 minus -8 squared. So in this case, it's really pretty nice that the negatives cancel out. So we get 5 squared plus 8 squared, which gives us 25 plus 64, which gives us the square root of 50, is that right? 50 now? 60, 80, 89. And then I can also put this as figuring out our calculator gives us 9.44 units, and that's why I use the approximation. I need to write that so it's better and easier to see for both of them. approximately 9.4 units. So these are the two answers we'd give for the distance. Now we want the direction. So we'll do two directions. The degree coming from the initial side and the ordinal direction. So we're going to need to graph this. So -5, -8, 5, 2, 3, that's -8. So it's about here. Oops, I went over one too many. -8, -5. Okay. -5, -6, -7, -8. So I keep this going down. Now I will go from the origin to -5, -8. Get this just right. Come on. Okay. Oh, come on. Oh, give me a second. I'll get this so it's better. All right, that's good enough. That will suffice for me for now. We're going in that direction. So we need to think of this distance, and then we need to find this distance. So this is 180 degrees to here, plus this amount. So you can use a protractor with either one of them. And I can find the protractor with this one shows that's a 58 degree, and that this one's a 32 degree angle. So overall here, this one, and I should do that actually as coming around like that. So 180 plus 58 is 238 degrees. So that's one of our two answers, because we're coming around like that. Let's write 238 degrees. That's A. But for B, we need to identify that this is south and that this is west. So we have south and west that we're in, and we need the angle in between. So that angle, starting with south, so you always start with south, just like with the north one up here, we started with the north one. So that's why the angle had to go this way. I had to start with the north and go to the line. Here we start with the south and we go to the line, which is 32 degrees. That line now. So we see that's 32 degrees, and that gives us our ordinal direction. Okay. If you were sailing, you would want to definitely be seeing it that way. Okay. So these are two good examples to work with. Now there's time for practice ones. And so I'm going to give you this one, -2, -9, again in the third quadrant. And I'm going to say that it's time for you to practice this one yourself if you're watching. Turn off the video, go and do this one yourself, and then come back to it and I will start going through the problem. Go ahead and do that now. Okay, welcome back. Let's go through the things to do with this. I don't have to graph it first, but I feel like it's a good starting place for me. So -9 would be 5, 6, 7, 8. This is about where -9 is, and -2 is here. So here's my point that I will use for graphing the ray that denotes the vector. All right, that one worked out pretty well to get to here. So that will help us in a moment with getting the direction. But the first thing that I want to do is to get the magnitude. So remember, that's called magnitude. And it's going to be the square root of And since we're going from 0, 0 to that point, oh, and I just realized some of you would have said something watching it, but I needed to put these arrows on it. Okay, now it's actually a vector. But we're going to go from 0, 0 to negative 2. 0 minus the negative 2 squared plus 0 minus negative 9 squared. So this is positive 2, and positive 2 squared is 4. This is positive 9, and positive 9 squared is 81. So the absolute value, like, but double that, is square root of 85 units, which is approximately 9.2 units. And therefore now we have our magnitude. Having done the magnitude, now we're going to do the direction. And first for the direction, from the initial side, so up to here is 180. And when I measure the remaining part of it, the remaining part of this is 77 degrees. So if I add these two together to get the total of all that, all the way around, I get 257 degrees. And that would be the answer I put here, 257 degrees. That's one of them. But now, instead of from the initial side, I want the ordinal direction. And for that one, I'm going to use the fact that this is south and this is west. And then the angle that I need is this one that's here, from the south towards the west. Well, that angle would be 90 minus the 77, or 13 degrees. Okay. And that means I need to use my south, put the degree in between, and then the west. And that's the other one. Okay, so that's those two. Now, here's another one that's not in the third quadrant. And this time I will remember to use the arrows. The arrow symbol there as the to denote that it is a vector. So please practice this one. Turn off the video, do it, and come on back, and I will go over this and as soon as you come back. Welcome back. All right, magnitude. So magnitude is going to be equal to the absolute value of 0 minus 5 squared plus 0 minus negative 7 squared. That means that the magnitude, negative 5 squared is 25, positive 25, positive 7 squared is 49. And that gives us a 50, 60, 60, 74. So it's square root of 74 units. And approximately, if I take that and put in the calculator, it's approximately 8.6 units. So those are our answers here. I think I want to put the approximation inside the box. So what this is the distance. Oh, okay, let's get this so it be. So I think I just need to go slower going through these. All right, good. Having done the magnitude, now let's do the direction. Oh, no, yeah, the direction. And the first part of the direction, oh, it looks like this is where it would be helpful if we graphed it. 5 and -7 would be about here. Okay, this will cooperate. This time it cooperated, yay. So what we want is all the way around to here. And then we see that this is south and this is west, and we're going to need the direction from south to west that way. So first, we have 180 to here. And if we keep going, that's 270 degrees here, which means if we find this distance, oh, which is the same as what we wanted there, we would add that to this 270. So we can find that by either doing a protractor to find from here to here, or protractor to find from there to there. So when I use a protractor, I get that this is 55 degrees. We're going the other way, so I'll call it negative, just to show the coming down from the 360. But if that's 55, I can do 90 minus 55 and see there's 35 degrees for this one. 35 degrees. So that tells us two things. All the way around to here is 270 degrees plus 35 degrees. Okay, that comes to 305. I could have done it where I could have done 360 minus 55 to get 305. And that would have given me the same as going around from the initial side. Either way, it's 305 degrees. Okay. And B, I know I have south, and I have west, and I need the amount in between, and we already figured it out with this being 35. Oh, hold on a second. If you caught this, you realize that that's supposed to be the east there. Okay. Now I think I'll just fix this whole thing. Now, let's do the magnitude. And the magnitude will be shown with that symbol, doubles that absolute values. And it's the square root of 0 minus 5 squared, we're using 0, 0 origin, plus 0 minus the -7 squared. So the magnitude, well, -5 squared is 25, plus +7 squared is 49. Okay. So the magnitude is equal to the square root of 74 for units, which is approximately 8.6 units. Okay, and there's our magnitude. Second, let's find the direction. And for the direction, it's going to help us a great deal to actually graph it. So 5 is over here, and -7 is down about here. So let's come over, find that point, and I'm going to draw this line to it. and have the arrow showing its array going from 0, 0, starting at 0, 0, going towards it, towards that point. Now, we are in the south and east quadrant, southeast, and we're going to do the directions in two ways here. I think I'll make that S look a little bit better there. So we're going to do the direction coming around this way, and we also want the ordinal direction, so it's going to be this amount going from the south towards the east. So first, the larger one is 270 to there, and then this little extra, which we'll need for both, right? So if we use a protractor, we would get that this amount, this amount comes to 35 degrees. Now, I have a couple of choices here. I could have also used the protractor to come this way and seen that it was 55 degrees, and I would have called that negative 55. And then at that point, I could do 360 minus 55 to get 305 degrees. Or over here, I could put these two together, do 270 degrees plus 35 degrees, and I still get 335 degrees. So A, 300 or 305 degrees, 305. For B, we need to use the south and the east. So it's going to be south and an amount in the east. And we don't even have to do a dividing by 90 unless we've done the 55 first. But with the 35 here, we can do 90 minus 55, or calculate with the 35, we get 35 degrees. So it's south 35 degrees east. So those are our two angle answers. And remember, this kind is called the ordinal direction. Just direction alone allows you to use that. But ordinal directions allows you, or means you must use this south and east kind of thing to do it. If I want to write the beginning of this a little better. Ordinal. Okay, great. Well, I hope that seeing this and doing this is helpful, and that it's been helpful for you to know how to do all of this now. Anyway, thank you for watching and listening.